So today's our topic is energy. So what is energy? Anyone know? What is energy? Suppose look at here. This is one stone resting on a plate, ceramic plate. So whenever it is resting on a ceramic plate, it will not break the ceramic plate. But same plate, and now you lift this stone to certain height. Then leave it. Whenever you leave it, it falls on ceramic plate, and the ceramic plate breaks into pieces. Here the example is, you have same stone and same ceramic plate. In the first case, you will not do any work. But second case, clearly the ball has done work. How can you say? Because it has done some work. Because of the work, it broken into pieces. That means the ball, same stone and same ceramic plate. But why in the second case it is able to do work? Why? We don't know. Now same thing, repeat it. Now lift it to double the height. Initially, the assume height is around 0.5 meters. Now assume you are dropping it from 1 meter. So what change you notice? Clearly you notice that in second case, whenever the stone incident on the ceramic plate, okay, here it does more work because same stone is able to do more work in the second case. Why? Anyone?
Displaces
Displaces? No. Anyone? Anyone? Same. Where same stone, same ceramic plate, but second case is able to do more work. Reason. I give you one more example. So you have a bullet. Okay, you have a bullet. So throw the bullet on the person. It will not harm him. But same bullet, whenever it is fired from a gun, then you can easily kill the person. Same bullet. No. No. Second case, the bullet has more something. So the first case, the bullet has ability to do less work, but second case, it has more ability to work. Why? Initially, first case, when you throw the bullet, maximum, as you miss the bullet, you may throw with velocity maximum 5 meters per second. That's it. Okay, so 5 meters per second, it strikes anyone, it will not harm. But same bullet, it's fired from the gun, you assume what will be its velocity? Its velocity around 400 meters per second or 300 meters per second. With this speed, easily can penetrate through a target. Understood? Okay, now one more example. Suppose hammer. This is hammer. Okay, here on iron nail. Okay, so this iron nail should be pierced into the red rock. Suppose when you place the hammer exactly on the iron nail will not go deeper into the red rock. But same iron, now you lift the hammer to certain height, now leave it. Now the hammer can able to displace. It will give sound. Sound is a form of because it is giving sound, it is doing some work. Okay, so take bow and arrow. So arrow, when you throw the arrow, it will not do anything. But same arrow is released from a bow, which is whose shape is changed. Then clearly the arrow has more ability of doing work. And you know, small kids play with toys. Okay, so when they wind up the key on the toy, then the toy can displace. If you don't wind up the key, then the toy will not displace. That means while you are winding up, exactly spring here, you are winding up. When you are winding up the spring is able to do more work. That means the capacity of doing work is called energy. The capacity of doing work is called energy. Okay. So how can you assess a person is more energetic or not? Just his ability of doing work. If he is able to do more work, we can find that he has more energy. Otherwise, you say that he has less energy. So what is the major source of energy for us? What is the major source of energy for us? Sun is the major source of energy. Are you getting energy directly from sun? No. How you are getting energy? How you are getting energy? Now you are energetic. You can do some work. If I dictate you class work, you can write. If I conduct exam, you are able to write. How is it possible? You came from ground floor to first floor because you have done some work, because you have energy. Have you got energy? By taking food. So food is giving us energy. But how the food gets prepared? Photosynthesis. In the photosynthesis, who is the major source of energy? Sun. So directly or indirectly, we are depending on the sun. Okay. So most of the energy needs are fulfilled by sun. Whether you are getting food only from sun. Not only that, you are getting solar energy also. Solar panels can convert sun energy into electric energy. So that energy we can use. Okay. So not only that, even small nucleus also can able to give energy. Nuclear energy. You know? What is that? Nuclear reactors. So most of the nuclear reactors are located nearby oceans. So nucleus, actually the energy what you are getting is very less from the atom. Because we are, whatever the reactions, actually you have a coal, when you burn coal what happens? You get energy. When you are burning coal, what actually happening? Actually, when you are burning is a chemical reaction. In chemical reaction only electrons will participate. So electrons will be shifted from one atom to other atom. As a result, the give excess of energy. That energy we use for our daily needs. Example, when you are burning petrol, the chemical energy you are using. If you are burning coal, the chemical energy you are using. So wherever you are burning something, okay, even your food also gets burned inside your stomach. So respiration, you are getting energy. So in all the cases, the chemical energy of the material we are using. The chemical energy only the electrons will transfer from one atom to other atom. But you know, nucleus has more energy than electrons. So I give you one small case. So 40 grams of nucleus energy is exactly equal to, almost equal to 40 tons of coal energy. That means by burning 40 tons of coal, how much energy you are getting? Same energy you will get from the nucleus. That much energy nucleus is. But what is the problem? Why we are unable to use much energy from the nucleus? So most of us we are using energy from the coal, thermal energy. We are getting electricity. How? By burning coal. By burning coal, what happens? Turbines will rotate. When the rotate turbines, mechanical energy converts into electric energy. That electric energy we are using. But we don't use nucleus energy. Even the 40 grams of nucleus I am telling you, very small mass. Just check here. 40 tons of coal, 40 grams of 40 tons of coal and 40 grams of nucleus. Both are able to give same energy. But what is the problem? So we have lot of energy sources around us, but the problem is we are unable to use it. We are unable to use it. We don't have sufficient technology to use the energy of the nucleus. Even though we use the nucleus energy, there are some side effects like radiation. The radiation may cause long-term problems. So that is why we don't use the nucleus energy. But in future, the technology may change. Then the people may shift from coal to nucleus. Okay, and what are there are many side effects of using coal energy because they are very limited, renewable or non-renewable. You know that non-renewable energy sources. Okay, so then you got an idea what is energy there. The capacity of doing work is called energy. So because the work done, we are measured in joules. Even the units of even SI unit of work done and SI unit of energy is same. Why? Because we measure work done and energy in terms of joule. Okay, joule. This is SI unit. Okay, and cbse unit you know that. And apart from these two, we have one more unit. What is that? Commercial unit of energy kilowatt hour. So where do you see this? kWh. Every month we pay bill, electric bill. You know, in Telangana government, below 200, you are not paying any bill. 200 is, what is that unit is? What is that unit? What is that unit? What is that unit? What is that unit? That unit is actually the measure of electric energy. How much electric energy your all electric appliances consumed in a month. So that is what your electric bill is. Okay, you are paying for energy used by you in a month duration. So the unit is 1 kilowatt hour. 1 kilowatt hour. So this is a commercial unit. So the appliances with more kilowatt hour, they consume more energy, then your electric bill will be more. So compare 1 kilowatt bulb and the 100 watt bulb, which consumes more energy? 100 watt bulb. Okay, actually that is not 0 watt bulb. Now the technology has shifted. We are using which bulbs? LED bulbs. So because LED bulbs consume less energy. Okay, understood? So kilowatt hour is the commercial unit of energy. So 1 kilowatt hour is equal to actually 36 into 10 to the power of 5 joule. This is the conversion factor. Okay. So this is small description about energy. And you know that there are many types of energies. Any one of you? What are the different types of energies you know? Light energy, sound energy, potential energy, kinetic energy, mechanical energy, chemical energy, nuclear energy. Okay, there are many different type of energies. Some of them are renewable energy sources, some of them are non-renewable. So renewable means you can use again and again. Okay, understood? So there are different type of energies. But here we are going to learn about a special type of energy called mechanical energy. So mechanical energy again divided in two parts. One is kinetic energy, other one is potential energy. The sum of kinetic energy and potential energy is called mechanical energy. So what is meaning of dynamo? Kinetic means dynamo. The word dynamo means something is moving. Kinetic energy. First form of energy. The energy possessed by moving objects is called kinetic energy. So let us derive an expression for kinetic energy. Assume this is mass, this is a block of mass mgh. Okay, initially it is moving the initial velocity of u. Then you apply force. When you apply force, what happens? You know, it gets accelerated. As a result of acceleration, its velocity changes to 3 meters per second. So the displacement of the block, let us assume as s meters. So in this case, the force must be constant. That means you need to apply the force throughout the journey, throughout the s meters. Throughout the s meters, you need to apply force. So when you are applying force, what happens? Some work is done. So clearly, this block has more capacity of doing work than same blank which is the initial velocity u. But because its final velocity is more than its initial velocity. According to our definition, the kinetic energy is the energy possessed by moving objects. So this is able to do more work. Now let us find out expression for kinetic energy. Okay. So we already talked about kinetic energy and we can measure the energy in terms of work done. So let us find out work done on the block. So work done, we know that work done is equal to force times displacement. So this expression we use only the force and displacement are the same directions. Okay, so displacement should be in the line of action. Line of action means in which direction the force is applied. So work done is equal to force into displacement. In this case, so what is the force applied? The force applied is equal to, we know, Newton's second law, force is equal to mass times acceleration. Mass times acceleration. So we know acceleration is equal to, we know, change in velocity by time period for which the force has been exerted. So you are applying a force, as a result it gets accelerated. What is the effect of the force here? The effect of the force is changing velocity. The velocity changes. So the velocity changes from u to v. How long you are applying force? You are applying force for 3 seconds. So we can get acceleration is equal to, okay, let us take this equation number 1 and this equation number 2. So final velocity minus initial velocity by time. Now substitute the value of acceleration in equation number 2. What we get? Force is equal to mass into acceleration, final velocity minus initial velocity by time. Okay. Now we already know that let us substitute this value of force in equation number 1. So what we get here? Force is equal to mass into changing velocity by time into displacement. Okay, understood? But here I don't want term s. How can I eliminate s value? How can you eliminate s value? How can you eliminate this value of s? How can you eliminate value of s? What is displacement here? How can you find out value of displacement in terms of velocity? We know that v square minus u square is equal to 2as. Okay.